Well, imagine you are prompting a user for a list of integers. Instead of using this code over and over, we can put all of this code into a function called getValidInteger and then just call it whenever we need a valid integer. So to do that, I'm going to create a function. I'm using the define getValidInteger. And then while true, we'll do all of that, and as soon as they've entered a valid integer, we'll go ahead and return it rather than printing it. So I'll just return num. And that would be our entire getValidInteger function. And then to use that function, I'll create a function called main. And I'll just say num1 is assigned getValidInteger. Num2 is assigned getValidInteger. And then I can print a message with the two numbers added together. I can say print num1 plus num2 equals, and then the result of num1 plus num2. And then I'll print end, and then to get that running, our entire program running, I'll go ahead and call main. So I've abstracted that logic to get the valid integer. When I run this function, I know this function will take care of all the work. It will keep prompting and get a valid integer, and when it returns the integer, I'm guaranteed to have a valid integer that I'll store into num1. And then I'll do the same thing on line 14. So by the time I get to line 16, I'm guaranteed these two numbers are valid integers because all the work was abstracted into a function that I wrote called getValidInteger. So I'll go ahead and run this. If I do a not a valid integer, 8, and then it's going to prompt me for another integer, and I'll just say cat not valid, and I'll put a 1. 8 plus 1 is equal to 9. So this would be a handy function that you could create and then use in any program where you needed to make sure you were getting a valid integer.